Hi Riverside, this is Mrs. Johnson. I am going to be sharing with you a quick-fire science experiment today. This is an experiment that you can conduct in your own kitchen without too much preparation. That's why it's called quick-fire. I would say that there's one item that you have to have and you can't use a substitute. That would be you need a bar of ivory soap. And ivory soap looks like, let's make sure I get this, like this right here. It's square, it's named ivory. I'm going to show you about why it needs to be used versus some other soaps. I'm going to take a bar of Dove soap, looks like this, it's kind of shaped like this, and I'm going to drop it in this container of water, and let's see what happens. All right, there we go. Now I'm going to do the same thing with ivory soap, and here we go. Here's my container. I'm going to drop it in. Wow, really different. This is why we need to use ivory soap. And I want you to ask yourself the question, what helps things float? And that's going to answer about why ivory soap. It's made a bit differently, and so because of it, it floats. So I want you to talk about that with your family about why that would be. And then you need a paper plate, and you need a microwave. And that's pretty much it. So here's what we're going to do. We are going to take a bar of ivory soap, and I actually have cut my bar of soap into smaller pieces like this, and that and then spread it out over the plate. That's just going to give us more surface area and make it a little bit easier to see what's sort of happening. And then we're going to put this in the microwave for about a minute and a half. All right, so into the microwave we go. Minute. My hands are all sticky from soap. Hold on a minute. Here we go. Let's try again. And I'm going to make it a minute and a half. And while that is in the microwave, I'm going to talk to you about just science in general. And one of the things about things carefully, and then you start asking questions about why you see what you see. What is making that happen? Why is that happening? And so when the soap comes out of the microwave, I want you to ask yourself, why did that happen? What about the soap was happening or being changed while it was heating up in the microwave? I want you to think about air. I want you to think about getting warmer. I want you to think about liquid or water, more specifically, all of those things. And I want you to talk about that with your family and see if you can figure out why the soap would be transformed the way it is. I'm not going to give you the answer. I want to see what you can come up with your families. And oh my goodness sakes, check it out. Talk about a change. Oh my goodness. And be careful, because it's kind of warm, and you're going to start seeing as it cools off, it kind of starts to shrink down. It's not quite as big, but you can just see, wow, what a cool transformation. Again, why did it happen? What did the soap have in it, and what was happening to it that allowed this to happen? Really, really cool. So once it's cooled off and it's kind of flattened, it will look kind of like this. It'll kind of shrink back down. And what you will do, it's interesting because it just crumbles apart. It's almost, some pieces almost feel like little pieces of torn paper. The neat part about this is that you can still use this soap. You could put these little pieces of soap and crumbles next to your sink in a bowl, and people can grab a couple of them and use this to wash their hands for 20 seconds versus using a hand gel or a hand foam like we normally use now. But it's actually, and it's really fun to crumble, and it feels really good. Anyways, this was our quick fire science.